Okay, I will explain the how we can going to use how we can retrieve the value from the secret manager. Before that, I will explain some. I want to explain connection pooling logic here. One more thing about the connection pooling. So let me just open my here. So what is the connection? We know what is the connection pooling, but how this connection pooling is work internally. Let me show you. Suppose this is our application and this is the end user. This end user visits our application. So what will it done? It will create a one connection pool. So it will create a connection pool here. This user when visits our application, it creates the connection pool, gets a connection from that connection pool, and it executes some query on our RDS. After these successful sessions, executing of or completing all these sessions, this user one closes all these sessions, his or her sessions. Then user 2 will come. Then what will happen? This user 2 again picks up the connection from that connection pool only and communicate with the RDS. So that is the main reason why the connections is not closed automatically or the pool is not destroyed here. Let me show you. If we execute our node.rds, node.rds.js, this is the main reason the pool is available for the another users also. So that user 2 will picks up a connection from that connection pool. User 3 will come and picks up the connection from that connection pool. If you end up the pool, let me show you the code again. After executing the query, if we end up the new pool.end in the try block also, then what will happen? Each user will come and create a separate connection pool for itself. So this is not the main purpose. After all, at the end, it will going to overwhelm our RDS and the CPU utilization might be high. So this is the reason the pool is ended at a finally block and not in the try block after executing the query. Now what will we see? How we are going to retrieve the password from the secret manager. So we are not going to define the password in hard code here. So we need to delete it. Now we want a password to be retrieved from our secret manager because our credentials of our database is stored in the secret manager. So let me just close it, ChatGPT also. So I will use the SDK of AWS JavaScript documentation. So this is the SDK. We need to go to the secret. So this is the secret manager. We need to install the package by using npm. Then only we can call over a secret manager service. So we need to install this package. Okay. Now, what is the code to get a password? So here we can find the command. So we need to get a secret value, which we can execute bad secret command and we can execute get secret value command. So this is our command. It's a simple, we need to provide only ARN, then we can retrieve the password. But how our application will communicate to the services of AWS? For the EC2, because our application is hosted on EC2, there is no need to configure the credentials of our account in a EC2, we can directly call our services. But in case of there is another server outside of AWS network, then how we are going to communicate with the services available in our account? For that, we need to use AWS configure. So by using this way, we are going to we can provide our access keys or access key ID and the region. So that is the another way we can communicate to our services available in our account. Another option is for the SSO, which is the single signing on services. It provides a token. It provides a access keys for the limited amount of time. I configured the SSO already. I configured SSO in last month maybe, but I forget about the concept of the SSO. So no worries, we are going to use AWS configure directly. But if you want any information about the SSO, how the SSO is work, and how we can retrieve the access keys and access key ID for the SSO, just follow the documentation, you will get to know. But for now here, we can directly calling our services because our Node.js application is available in our AWS network only. Before going to retrieve the password from user secret manager, we must have the valid policies for retrieving the password. So what I just did here, actually I got one role for my EC2 instance. So let me show you that role. So here is a role by Roshan EC2 SSM. This role is created by me for creating the session manager. Let me just open that role. And in that role, I define one inline policy so that I can get the secret from the secret manager. By the way, this is policies. This is a separate concept, but I will try to explain. So this is the first policy for creating the session manager. And this is the second policy created by me to get a value from the secret manager. So I will tell you how we can create it. So we need to just click on add permissions and create an inline policy. Before creating the policy, we need also to create a role for our EC2 instance. Suppose there is not any role in our EC2 instance and you are logged in as an administrator, then there is not need to configure the policy. But if you have any specific role to a EC2 instance, just like me, because of the session manager, we need to provide a policy explicitly so that this role can get the values or the secrets from our secret manager. Okay. So I will tell you how we define the policy here. So just click on add permissions. Create an inline policy. Choose a service or you can use a JSON visual or you can use a JSON. I'll prefer by using the JSON. Here we can choose a service. For service, I use secret manager. What type of action we want to define here in that secret manager? I want only the password. Get secret value. Yes. So we are getting only secrets. Do you want to add any resources? Yes, we want to add any add resources here. Service is a secret manager resource type. We want this policy retrieving. We want this policy allowing all type of resources only or for the specific ARN of a secret. In case of our architecture, there are two types of secret manager. There will be two types of secret ARN. Let me show you that. Okay. So there is a two types of secrets, separate secrets. First is for the RDS proxy, second is for the Redis. So that's the reason we are going to use all secrets. Or as well as if you want more security, you can create a separate policy and attach that policy to your role. The first policy is for the RDS secret ARN and second policy is for the Redis secret ARN. But for now, just for demonstration purpose, I use here all resources and created my inline policy. So let me show you that policy here. So this is the policy, same policy, which is allowed all resources for the secret manager, and it allowed only the get secret value. So okay, so and this is the code for retrieving the secret. So what will we do? We going to create another function for getting the secret, and we create another function in another separate file, so that we can use that file in our Redis configuration also for getting the secret. So let's back to our EC2 session manager, create another file as secret.js. We are going to create one function here again, which is a asynchronous function, get secret. So what is the syntax of getting a secret? For getting a secret, we first import a module here. So this is the module common JS import syntax. And this is a normal syntax here. Const client new secret manager config. Again, just because of this config word provided in SDK, I spent my entire 3 to 4 days just figuring out what is this config, because I don't aware about the AWS configure, and this config is actually provided by this config is actually a file and is provided by AWS when we configure AWS access keys in our server. But for now, there is no any file because the credential is by default available because of our IAM role. But we need to define the but we need to define here our what we say region here. So our region is AP South 1. Okay, we define the client here. Now what we want to define? We need to define here a version ID. Sorry, we need to define a secret ID. Secret ID is nothing but our ARN. There is no need to define the version ID and version stage. If you remember, version stage is just AWS current, AWS pending, AWS previous, as we discussed earlier. It's a required actually secret ID. So we need to define here our secret ID. Again, we can define a secret ID in the forms of environment variable. For demonstration purpose, I will define the secret ID directly here. So what is our ARN? So this is our ARN. I will just copy that ARN and paste it here. So if you just scroll down, it gives you one example also, and it just provide here the secret ID, the ARN or the name of the secret to retrieve. So we are going to provide the ARN only, and it is a required, and another is not compulsory to provide in the secret. After that, we are going to execute command for getting the secret. Again, this is not mandatory to remember all the commands, and it is not possible to remember all the SDK commands. So best way to just copy it and paste it. Just remember where to look. Okay, now we are going to use console.log to get the response. Again, we use if here to call this asynchronous function, one arrow function. For now, we are not going to use any try catch block. We are directly using if you want, we can if you want, you can define here a try catch wrapper. But for now, I will just execute this get secret, and if you want, you can also define a try catch wrapper in get secret also. Okay, so easy. So let's, okay, no issue. Define just try catch wrapper here. In case if there is any secret ARN also, then it also throws some error. Define try. Instead of console log, I will return the responses to my function. And if there is any error, this error will be thrown. If you want custom error, you can create a custom error also. I think the syntax might be throw new error dot message, something like that. For now, I will just throw the error. And we can catch this error in the try catch block also. Const data await get secret SECR. Because this returning some data to this function, we need to console.log that data. If there is any error, the error will be get caught here. And we console log that error. Now let's execute over this function. So we'll get to know it will retrieve the value or not from our secret manager. Node secret.js. Okay, syntax error, unaccepted identifier secret.js2. Okay, it's actually a function, asynchronous, it's a function. Escape :WQ. Okay, there is a syntax error while providing region. Okay, let's try again. I'm sure there we need to provide us here over a region here, but might be there is any syntax error. So let's. Okay, I think the syntax is like that. Region. Let's check it again. Secret is not defined. Okay, on the line. Okay, await get secret. Okay, now we get over a secret value, which is a username and the password. We can store this username and password, or we can return this username and password. So what we'll do, there is no need to get the metadata. So we want only the secret string to get returned. So let's edit over a secret code here. So it will return the response. Again, let me check it. It's a secret string. I will just copy that. There is no need to get a metadata. We want only the secret string here. Beam secret insert mode dot secret string. Okay, we get a string. Remember, this is not an object, this is a string. If you want a username and password, you can get that username and password. Let me just show you. We can pass this response in the form of JSON. So JSON.pass. So escape colon Q. again vim.secret. Okay, insert mode. It's a nightmare for me to use a vim. So json.pass, so that the string will get converted to a JSON. Okay, now the string is converted to the JSON. Now we have username and password from our secret manager. What we'll do now, we will going to instead of calling this function here, we are going to export this function so that we can import this function as a module in our code. So let me just show you. We can export. Let me confirm the export syntax. X module.export. It's exports or exports. It's exports equal to module.exports equal to. So what is the function name? It's a get underscore secret. Yes, module.exports get secret. So we successfully exported this function as a module so that we can import this function in our RDS.js also, and in future we are going to create one Redis file for getting the values from the Redis also. So this is the way we can manage our code by creating a separate function for connection, by creating a separate function for the query, and creating a separate function in the separate file for retrieving the values for secret, so that we can use that function in another snippet of the code for the Redis also. So let's get back. Now let's open our RDS.js. Now we need to import that module here. So again, const. The syntax is changed here. We need a get secret equal to require where it's stored. Let me just confirm the syntax again. Okay, it's stored in the same directory as a secret.js. Okay, the syntax is the same. Get secret is our function name, require store in the file secret.js. Okay, now here we are going to call the get secret function. So let's get started. So I will create one variable here as a credits, which stores our credential. We are going to call our function get secret. And we are going to create another function which is called as username. We store only the username from the credits, and for the password we are creating another variable called the password, and store the another credentials which is the password. So here I already type password. In username I will type here as a username. Let's try to execute the program again. Node RDS.js. Yes, we get a successful output, which means the value is get successfully retrieved by using the secret manager. Okay, so this is all about the making connection with our RDS and executing the query. Now, most important thing about the suppose there is an error while making the connection or while executing the query. Consider there is an error while executing the query. Suppose there is an error in a query. We got successful error. We get successful catch the error in our SQL syntax. So how we can resolve this? Show databases. So there might be a chances. What we need to do, we need to retry the query for the multiple times, or there is a might chances to retrying the connection for making a connection for the multiple times. So how we can implement that logic for retry, or we can say a retry mechanism for the connection and for the query also. Let me explain our diagram. Suppose while making connection, there might be any error because of multi-z failover or switchover. There is an error in a connection, or there is an error in a query. So in that scenario, what we need to do, if there is an error, we need to retry for the specific amount of time. We need to retry for the number of times. So we need to implement a retry mechanism for the function of connection also, and for the function of query also. So for that retry mechanism, I will going to create one. For that, just like retry mechanism, we are going to create another function which is called as a backoff logic. What is backoff logic will do? Suppose there is an error, then this backoff logic will be get called, and in case of connection also, and in case of query also, suppose there is an error while executing the query, this backoff logic will be get called. What is backoff logic what is backoff logic consists of? This consists of a number of retries. Let me type here. It consists of number of retries. So we need to implement this, the number of retries for the connection also, and number of retries for the query also. So you might have question why we need a separate function. As you all know, we want the same type of logic or the same block of code for the connection also and for the query. So just writing multiple times, it's better to create a function here. And in future also, for the Redis, we are going to implement the same logic. For making connection, we are going to create one function, and for executing the query, we are going to create another function. So to implement this in Redis also, we are going to create that function not in the RDS.js. So we are going to create one separate file called as backoff.js, just like secret.js, so that we can implement this function in our Redis file also. So let's just create one file here. Okay, it's executed successfully. Let's create one file here as a backoff.js. Again, this is a type of asynchronous function. So I will call this as a asynchronous backoff underscore logic. Again, this is a function. And what this logic will do, this logic will take a argument first argument is for the function, and second argument is for the number of retries. So here also we wrap it in a try catch block. Okay. Now, I will explain the structure of this back of logic code or the function. This back of logic function will accept one function as a reference function and accept one number as a number of retries. So whenever we want to, whenever there is an error or the error is get catched, what we'll do, we call this back of logic function. This back of logic function get one. Now I will explain. Suppose there is an error, then only this back of logic will be get called. This back of logic consists of one function as a reference function, and second is a number of retries. So let's get started here. What will it do? It will take, I will take it as a data equal to, we are going to call it await function, and we are going to simply return that data. But because of implementing number of retries, I want to implement here a while loop. So I will consider here as a one counter here. Let counter equal to 1 while counter is less than equal to retries. Then this logic will be get executed. And in error, we are going to catch the error. So when you are going to catch the error, we are going to catch the error if counter equal to okay, if counter equal to retries. If you know this equal to 3 times equal to, it's just for considering the data types also. If counter equal to retries, then what we want to do? We want to throw an error, whatever error it is. If you didn't specify this if condition, what will do? It will throw the error multiple times. So avoiding that, I implement this condition here. If counter equal to retries, it will throw the error. Catch block, it will increase the counter. If there is an error, it will increase the counter. Counter plus plus. So let me explain you. First of all, it will comes to in execution block of a while. Then it will comes to the try block, and this function and the reference of the function will be get called here. And if there is not any error, it will return the data. And our execution of the code will be stopped here because of a return statement. And if there is an error, it will caught by the catch block. Then it will increase the counter, and it will again check if a counter is equal to retries. Then only it will go to throw error. And if it is not equal to retries, then it again passes the execution to the while block. Then the number of retries is equal to the number of retries passes to this function. Okay. Now, before executing the back of or calling the back of logic into our RDS.js, let me explain one thing here. Suppose the number of retries is 6. So, okay. Suppose the number of retries is equal to 6. Then what will happen? As we all know, the execution of code contain the processes. Consider, it's just an example. This is a process number 1. This is a process number 2 for the retry number 2. This is a process number 3. And this is a process number 4, 5 and 6. Then what will happen? And consider this is our CPU. Okay, suppose the number of retries is 6. At the first retry, the connection is not get established or the query is not get executed. Second retry, it is not get executed. Third retry, fourth, fifth, sixth. Because of that concurrent execution of these all processes, all these processes running concurrently on our CPU, there might be a chances of high CPU utilizations, right? So to avoiding that, we need to implement some time in between two processes. So we need to implement a time in between two processes, which means that if the first process is get executed, after some amount of time, the second process get started. After the completion of second process, there will be some time or a sleep time, we can say. After that sleep time, our third process get executed. After the completion of third process, the time will be considered, or the sleep time will be there. Then the fourth process will be get executed on our CPU. So we need to create one function for the two processes. Sorry, we need to create one function as a sleep function to call between two processes, or we can say between the two retries, right? Clear here why we need one time or the time function here. Suppose we define a number of retries as we define your code, and consider there is an error in our connection. Then all this number of retries will be get executed at the same time concurrently. Then these processes will be also get concurrently on our CPU. This might be overwhelm over CPU, or there is a high chances of CPU utilization, high CPU utilization. To overcome this, we need a sleep time between two processes. So to implement this sleep time between the two processes, we need to implement this sleep time in number of retries also. Suppose the first retry is going on. After execution of first retry, there will be a sleep time. After the completion of the sleep time, then there will be a second retry. So we need to define a sleep function here, or the sleep time here. So how we are going to do that? There is not any inbuilt function in the Node.js. So we need to implement this sleep function. We can create this sleep function in the Node.js. Let me show you how we can create this sleep function. We are going to use a set timeout in our sleep function. So let's create our sleep function. I already created in my project. So let me copy paste it from there. So this is a simple sleep function. It's a type of a promise which resolves after a specific amount of seconds. I will just copy it and paste it here. So this is our sleep function. What will it take? It takes a it takes a number of retries. No, sorry, it takes a millisecond value here. So when it call to when we want to call this sleep function, we want to call this sleep function after the checking of this condition. So we'll call it as a sleep. So we need to define here 100 milliseconds. Consider this is 100 milliseconds. After 100 milliseconds, what will happen? The timeout will be get executed. This timeout will return one promise, or we can say after this timeout, our condition get resolved. Whatever we can say. So here is another condition also. Suppose this timeout is also 100 millisecond. This sleep time is also 100 millisecond. This sleep time is also 100 millisecond. In that case also, because of the same timing between the two processes, then there is no any logic for implementing the sleep time, because the timing is the same for the for the processes. To overcome this, we need to implement one logic to create a different time, where we can generate a different time, so that there will be no any mismatch between the two times between the sleep time of two processes, and there is no any concurrent execution of a processes. So how we are going to do that? So there is also one syntax I can say. I already created here. So this is a simple mathematic function which are going to create, which will be which created millisecond value. I will just implement it here. Okay, so every time when this error is get caught, this bat.minimum will create a one random number. So if you have question why we didn't use mat.random directly, because there is a chances where mat.random will generate the same number, and if the same number will be generated, then the sleep time will be the same, and there is a chances of again CPU utilization. So to overcome this, we need different sleep time for the each processes or between the each processes. For that, we are implementing this logic for generating a random number here. Okay, and we are passing that milliseconds in our sleep function. So we'll pass it as a ms, and instead of connection counter, we have here a counter only. And I get this syntax from again the internet. Okay, I get this syntax from the Google, so you can copy paste this syntax, and it's a basic logic for implementing the sleep function or the timeout. Okay, now our logic is get created. Now we need to export this module. For that, module.export. Let me cross check it again. Module.exports. Exports equal to backoff underscore logic. Yes, so we exporting this function successfully. Now we are now we can call this function in our Redis also and our RDS RDS.js also. So this is our code. Okay, now let's back to the RDS.js. Now instead of calling this in an error, if there is an error, what I said, we can call this backoff logic. But instead of calling this in error, what will I do? I directly called in a await function. I directly called instead of calling the execute query. So what will happen? If there is not any type of error, it will execute the query. It will return the data, and if there is an error, it will retry or implement the retry mechanism. So before that, we need to import that function. So const, it's a backoff logic equal to require it's presented in the same directory with the file name is backoff.js. It's a backoff underscore logic. Okay, let me confirm it again. Beam backoff.js. Yes, it's a backoff underscore logic. Now instead of calling in a catch block, I will directly call by executing the function. So instead of calling the query, I will call first backoff logic. In that backoff logic, I will pass the reference of the query. So if suppose there is not any error by executing the query, it will return the error. It will return the data. And suppose there is an error, it will retry. It will implement a retry mechanism. So this await backoff underscore logic underscore logic, and we'll pass one reference of the function, which is execute query, and the number of retries. In our case, it's a 6. The number of retries totally depend upon your use case of the application. For now, just I just pass here 6, and let's try to execute the program. Node RDS.js. Okay, we get the data successfully. So this is nothing but the back of logic with jitter. This concept is called back of logic, and the time which we implemented here is called a back of logic with jitter. So it's for executing the query. Then what about the connection? If there is an error, then also we want to implement the retry mechanism for connection. For that also we are implementing back of logic. So where we created the connection. Okay. So the connection is get created from the pool, and suppose there is an error in a pool, we are again going to implement the retry mechanism for creating the pool. So we are going to here call it await back of underscore logic. Now we pass a function reference here, number of retries. So this is the same thing which I tried to explain here. Yes, the back of logic in application. What this mean by application? In our code, the application means our IFI. This block of code. For now, we call this as an application. Because we called a function which is a back of logic as per diagram. In that back of logic, we'll pass the function reference as a function query. In function query also, we implement a back of logic and we pass the function as a we pass the function reference from the connection. Now let's execute the function. Okay, we get a successful data. So again, I will show you the code of our back of logic, backof.js. So this is our code. This leave function will set some timeout, or it's a type of a promise which get resolved after a specific amount of time. And what is the time? Time is in the millisecond, which is created in connection.milliseconds. It will create a random value, and this random value is not same at all. So this leave function is a unique, we can say. And we created a asynchronous function for back of logic, which will take a function reference and the number of retries. And we created a while loop here, which will going to execute for the multiple times or the equal less than or equal to the number of retries. And if there is an error, it will execute this function. It will execute this while loop again and again. And suppose there is not any error, it will get exited from the code because we define the return data here. So this is nothing but our back of logic with jitter. Okay, let me just copy it. Okay, so this is nothing but our back of logic with jitter, and this is how we can implement. This is how we can implement our AWS SDK with JavaScript, and how we can integrate secret manager to retrieve value from the secret. In next video, we will going to see how we can configure the Redis also, and how we can create one Node.js application to get a data from Redis. And then we are going to see another application in Node.js to check if data is available in the Redis or not. And if data is available in Redis, it will retrieve from the Redis. And if data is not available in the Redis, it will use the RDS.js here. Hello. In previous video, we just created one Node.js application, and with the help of that Node.js application, we successfully retrieved the values or the data from RDS, while the username and password is taken from the AWS secret. In further videos, we are going to see how we can get the data from the Redis. So as I explained in our architecture, let me explain you again. Now for the Redis, the credentials of the Redis like username and password cannot be get directly stored into the AWS secret. Just like RDS, it maintains all the credentials in AWS secret, and there is an option for integrating RDS with AWS secret. But for Redis, there is no such options available for integration of AWS secret with the Redis directly. So what we need to do, we need to create one Lambda function. That Lambda function helps to rotate the secret or maintain the secrets in the AWS secret manager. And this AWS secret manager will rotate the secret after a specific amount of time. In case of RDS also, this secret manager will rotate the secret to maintain the security, and the rotation of the secret is get handled by this Lambda function, or whenever the rotation is triggered, this Lambda function get invoked automatically. After invocation of that Lambda function, what we are going to do? We are going to do to generate a new secret by this Lambda function, and we store that secret in this AWS secret manager and store the same generated credentials or the username and password in the Redis itself. So this is the main working of this Lambda function. So now what we are going to do, instead of just launching the Redis first, we are going to create a secret and a Lambda function. In Lambda function, we are going to create another functions for generating the secret and storing that secret in the Redis. But for this video, we are going to create two functions in the Lambda. First one is for generating a random password, and second is to store that random password to our AWS secret. So let's get started. We can create two functions. Let's see how many number of functions we need in our Lambda function. So I just stop my RDS instance. Let me open Lambda function here. Okay, I already have one function which will help to rotate the AWS secret. Let me show you that. In this UI, it will not show that directly that it's integrated with our secret or the AWS Redis. But internally, this Lambda function is get integrated with our AWS secrets and our Redis. So this is my code. So the cache update is for the Redis update. SSM update is for the secret manager update. I will explain how we can do this. For that, I will create another Lambda function. We are not going to use the same Lambda function. So just click on create function. If you don't know about the Lambda function, what is a Lambda function? Basically, you can say it's a type of a serverless service provided by the AWS. So there is no need to manage any type of services, any type of server configuration. It is a fully scalable kind of server. We need to just define our code here. Whenever there is a invocation of Lambda because of any reason, this block of code will be get executed. The invocation of Lambda depends on different types of scenario. In our scenario, whenever there is a rotation happen in our AWS secret, it will invoke the Lambda function automatically. I will show you while creation of the AWS secret, there is an option for invoking the Lambda function. So we are going to create a Lambda function from scratch. Let's check if there is any blueprint available for Lambda function for the secret manager. Okay, just a hello world. So we are going to create a Lambda function by using a scratch. From the scratch. Function name, I will give the function name as rotation for Redis. Rotation for secret manager and for the Redis. A function with that name already exists. Okay, I already created that function. I will type here another name. Okay, Secret Manager and Redis. That's it. Runtime, yes, we are going to use a Node.js architecture. Permissions, I will show you the permissions related to it. I will create a new role with the basic Lambda permissions. Later on, we are going to change the permissions. Advanced settings, we are not going to check the boxes of advanced settings. Simply create a function. Okay, now our function is get created successfully. This is the basic syntax of the Lambda function. Okay, now we are going to create one secret in a secret manager for our Redis, which is nothing but a username and a password. So this is our Lambda function. Here we are going to create one secret. Okay, I need to sign in again. Okay, we have two functions, sm Redis and rotation sm. This is my another function. Okay, so let's start to create a secret or store our credentials for the Redis in a secret manager. For that, we need to open the console for the secret manager, store a new secret. It is not for the database, it is for the Redis. So we are going to select other type of secret. I will give here a username as Redis. We are going to add one more row here, which is a password, and the password will be, what should be the password? This can be admin1234. Encryption key, we are going to select the same encryption key. Next, secret name, I will give you a secret name as a Redis or for Redis. Description is optional. We can give a tags, resource permissions. There is no need to create a resource permission for the secret manager. Replicate secret. If you want, you can replicate the secret. Automatic rotation, or there is no any rotation for the secret. Yes, so we need to enable it to invoke the Lambda function. Rotation schedule, we can schedule the rotations after the specific time provided by us. This secret will be trying to rotate the secret, and where is get secrets generated? The secret is generated by using this Lambda function. So whenever this time is whenever this rotation is get happen, what this AWS secret does? This AWS secret will invoke that Lambda function, and because of our code contained in this Lambda function, it will create one secret by using this Lambda function and store that secret in secret manager, and also update that secret with in Redis. Rotate immediately when the secret is stored. Yes, we can define the window duration for rotation also. So we are going to use a new Lambda function, which is a sm Redis. Next, and we are going to create the secret. So here is the code for implementing the secret manager. Store. Okay, now it's not able to rotate. It will not able to invoke a Lambda function because there is not a policy, or as a principle, there is not a policy defined over Lambda function. So I will show you how we can define the policy, or how we need to show the policy. So this is our secret. So we what will now what we want to do? We want to create a policy or the principal policy so that this Lambda function will be get invoked by this AWS secret. For that, just click on configuration. If you see here, there is a one role for here which is created for the Lambda function. So we need to create here one policy here, which is a resource based policy. So what is this policy means? Resource based policies grant other AWS account and services permission to access your Lambda resources. Yes, so we need that policy. So we are going to click on add permissions. It's a AWS service, and what is this service? It's a secret manager. What we're going to use? It will invoke the Lambda function. So where is that Lambda invoke? Yes, Lambda invoke function. Statement ID we can give here as a default and save. Now what will happen whenever there is a rotation of the secret is going rotation of the secret, this AWS secret will invoke this Lambda function. If you just click on view policy, it will show you the created policy. This is nothing but our statement ID. Is the default effect allow on our secret manager, and what will it do? It will invoke our Lambda function. So this is nothing but our resource based policy. We need to add one more policy for this Lambda function so that this Lambda function will able to retrieve the value from AWS secret, and so that it will update the secrets in our Redis. So this is first requirement or the permission for our AWS Lambda function. Second permission is for rotating the secret. So there is, if we created a random password, that random password should be updated in our AWS secret. Then the updation of the AWS secret permission should be there for our Lambda role or the Lambda function. So to attach this policy to a Lambda function, there is one specific role which is by default created by AWS while we creating the Lambda function. We can see that role name here, which is SM Redis role. Let's open that role here. Okay, now this is the role and this is the policy attached to our role, and this role is attached to a Lambda function. So this allows only the logs related to the CloudWatch. So we need to attach one more policy. So how we are going to attach this one more policy? For that, we need to create a policy here. Add permissions. There is option for attach policy. If you click on attach policy, let me show you my created policy already by rotation for Lambda rotation. It is for rotating the Lambda, which allowed the get secret to get a secret from the secret manager, to update the secret in the secret manager, and it's for the elastic cache for modifying user also, and get random password is for generating the password. I will explain this. For now, this video, I will going to create one more policy here. So just click on create policy. Yes, we need a JSON. So what type of secret we are looking for? We are looking for a secret manager. And in secret manager, what we want now? For now, we just want to get a secret value. This is our first requirement. Second requirement is that we want to update the secret manager. So search here, update the secret. So version stage is different and update secret is different. If you click on info, you will get to know. Grant permissions to move a stage from one secret to another. If you remember, we will discuss earlier, there is a three types of stages: AWS current, pending, and previous. So we can manually update that stages of our secret. But what this AWS secret, it take care of it internally. So there is no need to manually handle it. We are going to use update secret directly. Add resource. Yes, we need to add resource. It's a secret manager resource type. It's for the all resources or for the specific secret. The Lambda function is available. Let me show you here. The Lambda function, as we discussed earlier in your previous video, is only applicable for the secret manager which is related to the Redis. So there is no need to attach the permissions for the all resources of the AWS secret. So we are going to select a specific secret and we are going to provide a specific resource ARN of that secret. So what is the ARN of for Redis? Its ARN is a secret ARN. So we just need to copy paste the ARN here. Add resources. For now, we are just what we trying to do by using this Lambda function. Whenever there is a rotation, we are just retrieving the value from the secret and we are going to update the secret. So this is two permissions I added to the role which is attached to our Lambda function. The role name is SM Redis role. So just click on create. Just click on next. I will give her a policy name as what should be the policy name? By Roshan Lambda function. It's Lambda function rotation 2. So this is our policy name. If you want to add tags, again you can add tags here. Okay, I will just give it a policy name here, right? Okay, I just type in the permissions. Okay, policy name, create policy. Now our policies get created successfully. So let's back to our role. I will open the role name directly from the Lambda console. Now we have policy for this role which is attached to the Lambda only for the CloudWatch. Now what we are going to do, we are going to add another policy which we created now and attach that policy to this IAM role. So just click on add permissions, attach policies, and I will just search here by Roshan, which is a version 2. And what this policy contain? This policy contain only the resource for the specific ARN or the secret manager which is for the Redis only. And what this policy allowed? It allowed only to get a value from secret manager and update the secret. That's it. So we are just click on add permissions. Now this policy is attached to the role which is attached to our Lambda function. So this is our Lambda function. If we just refresh here, maybe we get here some details about the secret manager also. Yes, our secret manager resource is get updated here. For the secret value, get secret value and update secret value. So we attach successfully our policies to our Lambda function role. So I will explain again what we did here. We defined one resource based policy here, which means that this Lambda function can be get invoked by the AWS secret manager. This first permissions we attach to the Lambda. Second, what we did, we open the role which is attached to the Lambda function and attach a policy which allows the get a secret from the secret manager and update the values in the secret manager. So these two permissions we created or attached in this Lambda function. Now what we are going to do, before invoking the Lambda function, let's change the its execution time. It's by default is a 3 seconds. So we need to increase the timeout here. Actually, this whole video is not just about the Lambda. Otherwise, I will explain all the things related to the timeout and all the options available in the Lambda. For now, just I will define here as a 30-second and use the existing role, which is available, which is attached to this Lambda. Click on save. Okay. Now we are ready with our roles and we are ready with our secret manager. So let's try to get a value from the secret manager which we stored earlier. So if we just click on, not on triggers, we are going to click on code. Let's maximize it. Okay, if you do console.log here, where will be the output? The output will be appeared in the logs of the CloudWatch or the CloudWatch logs. So if you want to test it, let me show you. So this is console.log, and I will give here hello from Roshan. I just click on deploy and try to test it and invoke that Lambda function. Okay, so let's check over CloudWatch logs. Monitor. We can click on view CloudWatch logs. So actually this CloudWatch contains the metrics related to the Lambda and the logs also. Again, there will be another video totally about explaining what is the CloudWatch and how we can see the logs related to the CloudWatch. But for the RDS, I will explain how we are going to monitor the metrics related to the RDS and the logs also. So we are in the log groups of Lambda SM Redis. This is a log stream. Timing is 6:34. So let's open the log. And yes, we got the output here. Hello from Roshan. So that's why I want to show you. If you do console.log, it will appear in the logs of the CloudWatch. Now let's start to implementing the logic of getting the secret from the secret manager. I use a AWS SDK to get a value from the secret manager. Here also we need to use AWS SDK. So we need to use the AWS SDK for the JavaScript. So this is the JavaScript SDK for the JavaScript. We can go from here also, but I will choose another link, JavaScript version 3. Always remember, just look for the version of a JavaScript you are integrating or you are using, the SDK or the SDK for the JavaScript. Because I spent my entire 2 days just to figuring out the I spending my more time just on version 2, and it is not going to work, and it's not going to work if you're using an older version of SDK. So always look for the newest version to implementing the code in your application. So let's open here a secret manager section. So before trying to communicate with the secret manager, as we see in my previous video, in our EC2 console we install one application, install the package for the secret manager. So how do we can install this module in our AWS Lambda? So in AWS Lambda there is no need to install the such packages, because it's available in AWS network. It can communicate to the AWS services internally. So there is no need to install such packages. So we'll directly search here get secret value command, same in the as we configure in our EC2 console. So we are going to import this package here, copy it, paste it outside the invocation, outside the scope. Okay, now we are going to get a ARN. Okay, simply copied it and pasted here. Remember, this is an asynchronous event. Okay, I just pasted here. I will explain about the config also. So there is no need to give a version ID, version stage in our case, because we want only the secret for now. Okay. Again, look after here. What about the config? Should we need to provide our access keys to our Lambda? Again, Lambda is an internal service available for the AWS. It can communicate with our another services available in the same account. So we can delete it and we can console.log here. So console.log response. Before that, we are going to provide a secret ID. Secret ID is nothing but the ARN, which we secret is nothing but the ARN for our secret of the Redis. Deploy, and we can invoke it from here also. So let's test it. Okay, error type, there is a reference error, so let's check it. Require is not a defined in ES module. You can use the import instead. Okay, so for here we need to use a import. Deploy. Now we are going to test it. Okay, so let's check the function logs now. (1641), yes. Let's open it. Okay, now we have a value of secret string, username and password here. We get a successful value of username and password which we created, the Redis and admin1234. So what does it mean? It means that the policy which we created for the Lambda function or for the role of a Lambda function, it's right. So there is no need to change in the policy for the role of a Lambda function.